Hi, Dr. Julian. Hi there.
Hello.
Hi, nice to have you again with us. Hope you're having a great day.
Yeah, good to see you.
Awesome. So let me welcome Dr. Julian Onions. So he's here to talk about the topic space and sustainability. So before we start, I would just like to thank Miss Wendy, Director of Knox Institute, for organizing this webinar. So Dr. Julian Onions, over to you. You can start your topic.
Okay. Could you let me share my screen? That would be...
Yeah, sure.
Okay, I think that's right. Can you see that?
Yes, Dr. Julian.
Fantastic. Right, I'm going to talk today a little bit about space and sustainability, and have to say I don't know a huge amount about this because it's a fairly new topic and something that not everybody is involved in. So anyway, this is my take on it. So I do hope you find something interesting in this. So I'll talk about sustainability in general, about something I'll come to, the low Earth orbit contamination rather, which is all about how we're putting lots and lots of things into low Earth orbit, satellites that come around and round, that you can see if you look up into the sky in a dark place. You'll often see satellites passing over, these bright, sometimes not bright, sometimes very bright objects that pass overhead. And there's a lot of them now in orbit. So if we actually look at, this is just a sort of a snapshot picture, this is what it would look a little like. So you can see lots and lots of objects in space, all circling the Earth, all doing different jobs. So some of them are watching the weather, so we get different weather forecasts that we can predict with some accuracy based on what we see from the weather forecast satellites. Some are communications, so some deal with telephone calls or radio or television programs that are bounced off satellites and spread around. Some are for the internet. There's quite a lot recently sent up to try and make an internet that covers the entire world. So no matter where you are, far out at sea or in a desert or anywhere, you can still get internet and phone calls. So there's lots and lots of those that are in orbit now, and this is just a sort of an illustration that it is quite crowded up there, and you have to be, if you're going to launch a new satellite, you have to be quite careful where you put it so that you get plenty of space and you don't run into anything else. There are also other things that are less welcome up there. There are results from previous satellites that were launched and have now been lost control of. So they're just orbiting and nobody can control them anymore because they've either run out of power or they've run out of fuel or something like that. So they're just drifting around and just getting in the way, really. They will eventually, depending on how close they are to the Earth, they will eventually slow down and fall back to Earth, but sometimes it can take 50 or 100 years or even longer if they're much further out. They may never come back to Earth. So it's a bit of a problem. There's also a lot of boosters that were used to push these satellites into orbit, so that they would get almost into orbit and then they would stay there as a booster rocket that doesn't have any function anymore, but is now drifting around. And some of these you can actually see with the naked eye, still floating around, tumbling in space, waiting until eventually the Earth's gravity will get hold of them. So if we actually look at what's going around in space and how it's changed over time, this is a graph you can see of things. So, you know, in the 1960s, we first started launching things into space, and people have been tracking them ever since because it got quite complicated, and you can see all these things. So the brown line is the total number of things floating around in orbit. And you can see it's got a lot worse, particularly as we get into the 2020s. And it's made up of various things. There's the blue line is the spacecraft. The orange thing is probably what I was talking about, this booster rockets that would push things up into space and then just not come back to Earth. And rocket bodies are also part of that. But this is something I want to talk about here in the pink line. This is something that is entirely sort of man-made and a real problem. So if we actually dig into this graph here, you can see this is when the first things happened. And you can see this, they sort of wobble up and so on. But there's occasionally these big spikes here. You can see here that it goes from just a few thousand to nearly 10,000 bodies orbiting the Earth. And all these have to be kept track of because you never know when one is going to come close to you. Well, you do if you track them, you can predict that. And the big problem with these is to go into orbit, you have to be going at a speed of about 17,000 miles an hour. So that's much, much faster than a speeding bullet. So if you're coming the other way, that's like 30,000 miles an hour that you're going to collide at. So that will be a bad day for anybody, that even a small nut or a bolt going at 17,000 miles an hour will punch a hole straight through whatever it hits. So there is a lot of energy in these objects because they're going around the Earth so fast. But you can see here, there's a big spike happens here and another one over here. So if we look into what caused some of those, this is one of those that was caused by an anti-satellite test weapon. So some of the military work on, obviously some of these satellites are very useful for military purposes. They can spy on other countries and see what's going on. So it's something that the military take great care of, and they would like to be able to disable some of these satellites in case of things go wrong. But you can see what happens here. This is where an anti-satellite weapon, in this case fired from China, and it hit this old Chinese weather satellite, and it broke up into all these little bits. And you can see as it goes around in orbit, it spreads out and makes a terrible mess. So it went from about 5,000 objects orbiting that we could keep track of to nearly 10,000. And some of those were close to the orbit of the space station. So the space station has to be moved out of the way when these sort of things come around, just to make sure. You can see eventually they spread out into a complete orbit. We almost have a ring of these things going around the Earth at that point. And whenever the ISS passes close by them, these have to be tracked very, very carefully to make sure that nothing actually collides and the astronauts are not in danger. So on a couple of occasions, they've actually had to move the space station. They predicted that it would come very close to an object, and they had to move it and boost it up into its orbit just to move away from these things. So this sort of test, and several countries have now done such tests, though not very recently. But you can see how unpredictable it is. You have a big explosion from this anti-satellite weapon that blows apart this old satellite, and the debris from it just goes everywhere. You can't really predict ahead of time where it's going to go. It will just go everywhere. So there's lots and lots of these like flying bullets shooting around the Earth at very high speed. And the people like NASA and other places have to keep very careful track of these with radar or other things, just so they know what's going to happen. Now, another case that also caused a problem was, in this case, this is where two satellites were actually on a collision course. Eventually, after some time, I think one of these they lost control of, perhaps the Iridium satellite and the Cosmos satellite. You can see they're going in sort of opposite directions, about 90 degrees to each other. but it was predicted they would hit. So they knew, I think days ahead of time, these two would hit and collide with each other, but there was nothing they could do about it. They didn't have control of either the satellites. They didn't have enough control of them to be able to switch on the engines, or perhaps they'd run out of fuel or something like that. But in any case, there was nothing they could do. They just had to watch, and these two satellites hit. And then we got another explosion of debris, which you can sort of see over here, all this debris that showered around. So that's another few thousand objects that have to be tracked and kept accounted for. Because if you're going to launch a spacecraft into orbit, you have to be wary of this and work out exactly where you're going to put it so that it doesn't come into contact with that. And to take it to its extreme, the worst thing that could happen is something that Donald Kessler came up with, who's a scientist. He came up with something that was later shown in the movie. Oh, what was the movie called? Can't remember. It was about people working on the space station when they got hit by debris. Perhaps it will come back to me. But in that case, you get a bit of debris hitting a space station, which explodes, and you get lots more debris. So that debris goes around, and then that perhaps hits another satellite, and you get even more debris. So you can see it's sort of a runaway effect of one set of debris hitting something, making even more, which makes even more, which makes even more. And eventually, in this syndrome, there would be absolutely nobody left, or no satellites working that would be left over. It would all just be junk flying around. So this is an illustration of that. You can see just things go very badly wrong when that happens. You get all these things. So what can we do about it? Well, people have suggested ways to clear up space, to go up there and clean up things, but it's a very difficult process to do anything about, because space is so big. There's so much volume of space around the Earth, which is lucky. That does stop us having collisions all the time. But to make a sustainable system, they have looked at ways of actually collecting things. Now, it's not too bad if you're going after a huge rocket body or something like that. You can actually have a device like this that you can launch, and its sole task is to get up close to this old satellite. In this case, this is Vespa. So they've got something that they would launch. It would slowly move up. It would capture the satellite, and then using its own engines, it would slow it down, and it would crash into the Earth and just burn up in the atmosphere. But at least it would be gone. So that would work really nicely for very large objects that you knew where they were, and you could afford to launch a spacecraft, because it's still very expensive to launch a spacecraft up into orbit. So you could do a few of those missions and collect some of the bigger bits. Other people have looked at doing this sort of thing, having perhaps a huge net that you could catch objects with. So again, that would work with some of the bigger pieces where you couldn't actually connect to them because they weren't designed to sort of be connected to. So here they look at having a huge net that entangles it and then just slows it down and brings it back into the atmosphere so it burns up. And there have been other suggestions of sort of magnetic things and special other processes. But the amount of time and effort you have to put in if you wanted to sort of really clean things up, if you wanted to go after like nuts and bolts that were dropped from objects, or little bits of satellites that were hit by these anti-satellite weapons or by these collisions, it's a very, very complex job. I mean, it would be like sort of going around your house looking for I don't know, grains of salt or something like that are scattered around your house. It would be a very tedious and very awkward job to do. Be much worse if you had to do it with a very long pole or something like that, pick up grains of salt with a long pole. It's just very, very difficult to think of a good way of doing it when there are thousands of grains of salt or something like that to pick up. So it's a similar thing in space. There's so many of these little objects floating around, and we don't know of a good way to catch them because they are, they are moving very, very fast. So you can't really just stop and catch them because they would just punch through you. You have to wait for them to come up. So a lot of more modern spacecraft are now looking very closely at this. In fact, it's now an international agreement that if you put a satellite into orbit, you have to come up with a plan to get rid of it at the end of its life. So it's although it's hard to get a satellite into orbit, it's now a little harder because you have to also say how you're going to get rid of it so that we keep a sustainable patch around the Earth for useful things as well as all the junk that's floating around there. And quite a lot of the rocket builders now, and in particular SpaceX, I'm sure you've seen this, the SpaceX landing, they take particularly care to bring back their used hardware. And in SpaceX's case, and a few others who are now copying them, they actually bring back the spacecraft so they land nicely on Earth, which I'm sure you've seen this sort of thing where they, these are the booster rockets.
I have seen the full one, even when you were launching.
So it's a very good way of keeping space clean by bringing everything back. But in this case, it's also very economical because they can reuse these boosters when they're done with it. I'll show you that. There we are. It's fantastic to see, and they're doing it regularly now. So not only are they not polluting space, they're now getting the chance to reuse these things over and over again, which brings the cost down quite a lot. So that's a great idea. Longer term, though, what we could do is actually not take so much stuff into space at all, but we could go into space and get it there. So there are suggestions that you could go to an asteroid, which is just a big lump of rock. Some of them are made out of rock, some of them are made out of metals and iron and nickel and things like that. So you could actually land a spacecraft on them and set up a mining facility actually on the asteroid out in space and make the materials there rather than making them on Earth and launching them into Earth's orbit. You could make them out on asteroids and make everything out in space. I don't think we're quite there yet. I think it's a difficult job to do to actually make stuff in space, but this is something that over the next 10 or 15, 20 years maybe might well come true. So this is something that you guys can perhaps focus on if you ever become engineers or astronauts or something like that. You might well find yourself working on asteroids out in space, making things that are cheaper to make in space than they are on the ground. So that might well be something you end up doing in the future. So I've just got a few minutes left, so I'm just going to summarize that. The first point is that these random collisions between satellites that just happen, they're extremely dangerous because they make so much space junk that we can't really control or keep track of. And anti-satellite weapons are also very dangerous because they just pollute the atmosphere of or the orbit of space. So there haven't been very many recently. People, even the countries that have launched them just to demonstrate they can do them, have seen how dangerous they are, not only to the satellite but also to all the other satellites that they depend on. So things like the GPS system that lets your phone know where it is, that would be affected by some of these things if some of those GPS satellites got knocked out. Same with your TV programs and internet. They could also be have a problem with these. So that's why all modern satellites have this end of life plan. How are we going to get rid of them after they've done what they've done? We've looked at a few ideas for cleaning up space, but it is very difficult. You can certainly go after the really, really big things that because they will fall into the Earth's atmosphere normally after a period, but it might be tens, even hundreds of years. So just by slowing them down a bit, you can get that to happen a bit quicker. So that's why you can look at some of these ideas of cleaning up space. But really, it's not such a problem for these very big things because we know exactly where they are. They're easy to find on radar and we can predict where they're going. It's these little bits like the nuts and the bolts, and somebody working on the International Space Station dropped his toolkit and it just drifted away. So there's now a toolkit circling Earth at 17,000 miles an hour. So anybody's tool bag going at 17,000 miles an hour would be a dangerous thing. So there's lots of these little objects, and they're the kind of the more dangerous because they're much harder to track, and there's nothing you can, there's no signals you can send to them or anything else. They're just bits of debris floating out. But I'm hoping that in the future we'll be working out in space much more, that perhaps people like you will be astronauts in space, doing work out there and helping to clean things up. So that's a hope I have for the future. With that, that's kind of all I've got to say on the subject. So I'll stop sharing my screen, and if you've got any questions, I'll be happy to have a go at answering.
Thank you very much for that, Dr. Julian Onions. I remember the movie. I think it was Gravity, right?
Gravity, that's it. Oh, well done. Yeah, I knew somebody would be cleverer than I was. Yes, that's it. Gravity with Sandra Bullock, was it? And George Clooney. Yeah.
2013.
So yes. Yeah. So they had a big disaster, and it made another disaster, and it just kept on being disastrous. But it all ended well for her, at least.
All right.
Yes. So thank
I
you very
think
much
we
for that.
have a question from Sudhita. Yes, sir.
If we can't collect the small bits, how can we collect? If we can't collect the small bits, when in the future, how do we think we will collect them?
I don't know. That's a really good question. I mean, they are very, very small, so it's not easy to collect them. I think we need to think up new ideas for doing that. So I think we need new engineers and scientists who can think out new ways of doing this. There have been lots of ideas about collecting these bits and pieces, but mostly going for the big bits because they're the easy ones. I have no idea how to get the smaller bits. I don't know whether you could do something with magnets or something like that would collect them together, or big nets. That's another possibility, but I really don't know. I think we're going to need somebody brainy to come up with that idea. So it could be you. Perhaps you'll work out a way to do it in the future. Who knows?
Got any more questions, Sudhita? All right. Ayusha, do you have any questions?
Actually, how then? When we collect the big bit, are there any more other ways that you think we can collect? Now I know we can collect from the net and from some other space telescopes that will attach to them from one graph. What do you think other ways that we can collect it?
I don't really have a good answer to that at the moment. I think it's got to be, we've got to think of new ways of doing it. There are ways you can have, like blocks. It's not blocks of concrete, but blocks of material that will absorb things. So when they get hit, things like they use on firing ranges to stop bullets, like sandbags or something like that. So you could get something that comes into it and hits it and slows it down. It doesn't have to be slowed down very much. The slower you can make it, the closer it will get to Earth, and then as it touches the atmosphere, that will slow it down even more. So you only need to sort of start it on the path towards slowing down, and you'll end up capturing it by the Earth, and then it will be gone. Most of the small bits will just burn up like a meteor in the atmosphere. You'll see a brief shooting star, and that could be a nut or a bolt or a screw or something like that, just burning up very quickly. So it will never get down to Earth. It needs to be very, very big to actually get down to Earth or be controlled in some way. Good question. Thank you.
I have no other questions, sir.
All right. Are you sure you may ask your question?
Excuse me, Dr. Julian, you said that after a few years, those things will come crashing into Earth's atmosphere now. Why should we go to space? We can do the experiments at Earth now when the stuff enters our atmosphere.
Yeah, it depends how close the orbit are. So you can put it in to an orbit that just goes outside the atmosphere, and then that will slow down and fall into the atmosphere eventually and burn up. But if you put it much, much higher up, it takes a long, long time for enough drag to happen for it to get close to the Earth. So if it's quite high up, it could take hundreds of years before it slows down. And you can also put satellites into geosynchronous orbit, so they orbit at the same rate as the Earth spins. That's where quite a lot of communication satellites go, and those will probably never fall down into the Earth's atmosphere, but because they're a lot further away, they're not so much of a nuisance. But yes, you can do lots of experiments on Earth, but testing them out in space is always quite hard, because it's a very different environment. You don't have any atmosphere there. There's no sort of gravity. Doesn't quite feel the same way. You've also seen astronauts just floating around and putting a pen in the midair and it stays there. So it's a lot more difficult to design engineering solutions that work in space than it is on the ground, because we've had thousands of years of practice doing it on the ground and only a few years trying it in space. So that's why it's a lot harder.
All right. Thank you for that, Dr. Julian. So I think those are the questions for today. So thank you very much for accepting the invitation and joining us once again. So have a nice day, Dr. Julian Onions. Let's wind up the session.
Right. Thank you very much for inviting me again. And you have a good day too, everybody.
Bye, Dr. Julian.
Bye, Dr. Julian. See you another day.
Yeah. See you another day.
Work hard.
I'll try.